Today's lesson is on equivalent fractions and decimals. Fractions can be written as equivalent decimals and vice versa. It's important to understand how to convert from one format to the other to better understand their value and to compare numbers accurately. Today we will compare numbers by putting them in the same format. So the first thing we're going to look at is how to take a fraction and turn it into a decimal. You simply divide the numerator by the denominator. This will result in either a terminating decimal, repeating decimal, or a non-terminating, non-repeating decimal. If you're not sure what those look like, a terminating decimal will always end, like 2.45 or 85 hundredths or 0.85. Repeating decimals, however, will repeat a pattern forever, like 3.45, 45, 45, and these three dots indicate that that's going to continue forever. Or 0.88888, and it's going to continue forever. Non-terminating, non-repeating decimals, however, would be a decimal where you do not see any kind of pattern repeating, like 3.14159265, which are the first few numbers of the digit pi, or 4.67981. You can see none of the digits actually repeat in either decimal. So let's take a look on how we can actually convert a fraction into a decimal. So when I said you simply can divide the numerator by the denominator, that's true. So if we had 3/4 and we wanted to convert that into the equivalent decimal, we're going to take that numerator, 3, and divide it by that denominator, 4. You can also do this on your calculator quite quickly, but let's do it the old-fashioned way. 4 will not go into 3, so I'm going to add a decimal and immediately put it on top of that division bracket and a 0. 4 will go into 30 exactly 7 times. That's 28. When we subtract, we get a remainder of 2. Since we do still have a remainder, we have to add a 0 and bring it down. 4 will go into 20 5 times, and 5 times 4 is exactly 20. So 3/4 is equal to 0.75. Now this 0, you can either have it there or not. It's not really necessary. So there's my final answer. 3/4 is equal to 75 hundredths or 0.75. In example 2, we will take that numerator 6 and divide it by 5. Since 5 will go into 6 exactly 1 time, 1 times 5 is 5. When I subtract, I still have a remainder. So that means I need to add a decimal and then a 0. When I bring down that 0, 5 will go into 10 exactly 2 times, which 2 times 5 is 10. So 6/5 is equivalent to 1.2. In the last example, I'm going to divide 1 by 3. I need to immediately add that decimal and a 0 because 3 will not go into 1. 3 will go into 10 exactly 3 times with 1 remaining. So it looks like even though I'm going to add a 0 and bring it down, I'm constantly going to be faced with a 10 there. So that means this 3 is going to constantly repeat. So to show that, I can either add that additional 3 and then add 3 dots to show that it's going to keep repeating forever, or I can simply say that 1/3 is equivalent to 0.3 with a line over it. This line is a way of telling the reader that it's going to repeat forever. Or you can also do the little 3 and just show that that's going to keep going forever with your 3 dots. Before we talk about how to go from a decimal back to a fraction, I want to mention the place value system. It's super important because each number in a decimal actually has a certain name for its place value. So for instance, here's where our decimal point is. If I move to the left, that's the ones position. If I move over again, that's called the tens position, and on. If I go to the right of the decimal, the first position right here is called the tenths. It actually has THS on the end of it. The next position is the hundredths, thousandths, and so on. This is really important to be able to refer back to, because when we do our next example of converting a decimal to the equivalent fraction, you'll need to know a little bit about place value. So basically, here's what you do. You locate the last digit to the right of the decimal. Determine this number's place value and use it as the denominator. The original number is your numerator. Then, of course, you have to always simplify your fraction to lowest terms. So let's go ahead and take a look at an example. So the first thing we want to do is take this decimal and turn it into a fraction. We locate the decimal point. It's right here. We go all the way to the last digit to the right of the decimal, and then ask ourselves, what is that 6? What place value is that 6 actually in? Well, the 0 is in the tenths place value, the 3 is in the hundredths, the 6 is in the thousandths place value. So that thousandths is going to become our denominator. We keep the original number, 36, and put it over 1,000, because whatever place value this last digit is in becomes your denominator. From there, you're going to reduce or simplify to lowest terms. Well, I know both of these are even numbers, so I know for sure they're divisible by 2, but I also know that 36 is divisible by 4, and so is 1,000. So if I divide both of them by 4, I get 9 over 250, and that is in lowest terms, so there's my final answer. So in other words, 36 thousandths is equivalent to 9 over 250. So I could actually compare them when they're in the same format. Let's try example number 2. Now in example 2, I actually have a whole number 1, and then I have a fraction of a whole number. So in this particular problem, the 1 is automatically going to stay. Moving to the right of the decimal to the very end, this 8 is in the hundredths spot. So I'm going to keep what is to the right of the decimal, 28, and rewrite it over 100 because that 8 is in the 100ths place value. Then I'm going to simplify by reducing them again. Oh, it looks like both are divisible by 4 again. So I keep the 1. 28 divided by 4 is 7. 100 divided by 4 is 25. So 1.28 is equivalent to 1 and 7 over 25. In the last example, this 8 is in the tenths place value, so I just have 8 over 10 to begin with, but since both can be divided by 2, I'm going to divide the 8 by 2 and the 10 by 2, and I get 4/5. So for this one, 8 tenths is equal to 4 over 5, or 4/5. So why I'm teaching you to convert from fractions to decimals and decimals to fractions is because when we compare fractions and decimals, it is important that the numbers you're comparing are in the same format. Then when you go to compare them, it's way easier. So for example, let's say our problem asked us to take 7/8 and compare it to 756 thousandths. You could either take 7/8 and turn it into a decimal, or change 756 thousandths into a fraction. It is much easier to change a fraction into a decimal and then compare the two decimals. So I'm going to figure out what 7/8 is equivalent to as a decimal. So in order to do that, I am going to divide 7 by 8. I take the numerator and divide it by the denominator. Since 8 will not go into 7, I need to add a decimal and a 0. 8 will go into 70 exactly 8 times, and it's going to have a remainder of 6. So I'm going to add a 0 and bring it down. So now I have 60. 8 will go into 60 7 times, that's 56, and it looks like I'm going to have a remainder of 4. When I add one more 0 and bring it down, I have 40, 80, 8 will go into 40 5 times, and that is exactly 40 with no remainder. So 7/8 is equal to 0.875. Now I can compare that to 0.756. So when you're comparing decimals, you start wherever the decimal is, and you compare if they have a first digit. Those are both the same. Then I have an 8 compared to a 7. So this number is larger than the 756 thousandths. So if I were comparing these numbers now, I can say 7/8 is greater than 0.65, or excuse me, that's supposed to be a 7, 0.756. And there we go. That's all there is to it. Thank you for watching.